All right, people, polar coordinates day 1. So we're looking at points, but we're not looking at points based on our normal XY axis. We're looking at points based on, based on their radius and theta. So the idea is that this pole, this center, this origin is set in stone. And the question about this point P is, how far around that center origin does the axis have to go to get to P, right? Then we're focused on the radius. Okay, so what I think about is this. If we look at something we already know. So the first idea may be a little shaky, but if we look at something we already know. If I look at rad 2 over 2, comma, rad 2 over 2. That's our xy point, rad 2 over 2, comma, rad 2 over 2. But if we think about it for this polar coordinate, right, there's what we're rotating around. I got this line here. Now, since this is a unit circle, we all know that the unit circle is 1. If we start on our polar axis and rotate up, how many degrees do we rotate? Pi over 4. So in an xy coordinate, rad 2 over 2, comma, rad 2 over 2 works. But in a polar coordinate, this is the point 1, comma, pi over 4. The point is 1 unit away from the origin, and we rotated pi over 4 radians to get there. Now, so imagine we had a point, I'm trying to give us some space here. Imagine we had a point, so if we have here, we have negative rad 3 over 2, comma, half. So there's our xy point. There's my radius, which is 1. Now the question is, how much do I rotate around? So if I got negative rad 3 over 2, comma, half, we're talking about a radius of 30 degrees. So we're talking 150. So the point, negative rad 3 over 2, comma, half, can be written as 1, comma, 150 degrees, or we could write it in radian form, whatever works, right? Whatever the problem is telling us. So this is our situation in terms of polar coordinates and an xy, axis. Polar coordinate, how far from the origin, how many degrees we rotate around to get to that point. XY, we're just talking about the x-axis, y-axis comparison. Now with polar, we have a different looking graph. But, being honest, this is the exact same graph we've always had in the scenario that you've always worked with. I can't get this to move for a second. Alright. So again, the idea is how much we rotate around and how far from the origin. So we are always rotating starting at this, right, our 0 degree, our polar axis. So if we're graphing 3 pi over 6, so we go to our pi over 6 and we go 3 units from our origin. So right there, that is 0.1, 3, comma, pi over 6. All right, 3 pi over 4. So we're over here. We're 4 units away. 1, 2, 3, 4. That's our 0.2. 5 pi over 3. 5 pi over 3 is, where are we at 5 pi over 3? Oh, 5 pi over 3, all the way down here. All right, so 5 pi over 3, and we're 1 unit away. So we are, come on, work. Right there. So there's our 1, comma, 5 pi over 3. And the idea is for all these points, what's happening? We're starting here, we rotate pi over 6 radians, and we're 3 units away. We start here, we rotate 3 pi over 4 radians, and we're 4 units away. For this one, we rotate all the way around almost, and we're 1 unit away from the origin. So if we graph a few others, things to consider. At 13 pi over 6. That's larger than 2 pi. So this is the exact same thing as 3 comma pi over 6. Right? They're coterminal. They're in the exact same spot. So 3 comma 13 pi over 6 that works. 3 comma pi over 6, that works. No, if we want another example, 3 comma 25 pi over 6, that works. Another example, 3 comma, if we go negative 11 pi over 6. All those are the exact same point, the exact same spot. Okay, negative 4, 7 pi over 4. All right, so a little bit different idea here now. We got negative 4. So we go to 7 pi over 4 in our graph, which is here. I'm going to change that. But since we're negative, instead of going the normal down the axis this way, we reverse. We go through the origin, and we end up 4 units that way. So we loop around 7 pi over 4, but we don't stay on there. We go back through the origin, negative 4 units. So in the end, this is the exact same thing as we see example 2, 4, comma, 3 pi over 4. Those always match up. So what are some other examples? Well, if I added 2 pi to it, I could have, another example could be 4 comma 11 pi over 4. I could add 2 pi to have another example. Maybe I got negative 4 comma 15 pi over 4. All of those are the exact same thing. All right, but here's the key thing. All right, key fact. Sorry. Nope. All right, when r is less than 0, meaning it's negative, the polar coordinate is always the absolute value of r, comma, theta plus pi or theta minus pi. So if we look at our examples, with this negative, the absolute value of 4, negative 4 is 4. Then if we add pi, which would be pi over 4, we have 11 pi over 4. If we subtract pi, we would have 3 pi over 4. So both of these are acceptable positive answers for negative pi over 4. By using the pi, think about it, it's 180. Think about that saying, like, give a 180, you turn around. Well, in this situation, you give a 180, you end up on the opposite side of this polar graph. So for this last one, another option here. So if I start this off, I could make it negative 1, comma, go to coterminal pi over 3. Well, then that means that's an acceptable answer. But if I want a positive r, 1, comma, if I add pi, 4 pi over 3 is another acceptable answer. So whichever one you want to go with, doesn't matter, it's fine. So there's many answers in that scenario. All right, so talking back to the rectangle, the xy. So if we were to graph 2 comma 2, right, there's 2 comma 2. If we wanted to find its polar coordinate, so if I make, 2 comma 2. So if I make my triangle, like we always do, with theta there in the middle. All right, there's my right triangle. So my polar coordinate, I need radius and I need theta. Well, how can I find radius here? Simple, Pythagorean theorem. X squared plus y squared equals r squared. So here we got 2 squared plus 2 squared equals r squared. R equals 2 rad 2. Right, there's my radius. Now if I wanted to find my theta, I have all 3 sides of the triangle, but if I just stick with the x and y, I have tan. Tan theta equals opposite over hypotenuse. Right? I meant opposite over adjacent. So we have the inverse tan of 1 in this situation. Inverse tan of 1 is 45 degrees, giving us our point in this situation to be 2 rad 2, comma, pi over 4. These are the exact same things. One is a polar xy axis, and one is a I meant one is a rectangular XY axis and one is a polar coordinate. Same spot, different idea. So one thing that's going to be consistent is to find your radius, take the square root of x squared plus y squared. To find theta, always take the inverse of x over y. Now hold true every single time. All right, what do we do if we have a polar coordinate? So if I think about my graph, I'm in the first quadrant. I'm 3 units away, and I got pi over 6 as my radian measure. All right, so that's what I got there. So I need to solve for y, I need to solve for x. To solve for y, I got sine of pi over 6, equals opposite over hypotenuse. So that gives me y equals 3 sine pi over 6, which in this scenario, pi over 6 is a half. 3 times 1/2, y is 3 over 2. If I wanted to get my x value, I would go cos pi over 6 equals x over 3. X equals 3 cos pi over 6. So pi over 6, I got rad 3 over 2. So this would be 3 rad 3 over 2. So there is our rectangular xy coordinate compared to our polar coordinate. So every single time to find x is radius times cos theta. To find y is radius times sine theta. All right, got some practice examples here. All right, so I'm looking at this first one. Pythagorean triple. Radius is 5. Now if I do the inverse tan, in this case of 4 over 3, I use my calculator, I get theta equals 0.927. My point is 5, comma, 0.927. Done. A Pythagorean theorem over here. X squared is 3, 1 squared is 1, equals r squared. R equals 2. Awesome. The inverse tan of, in this case, 1 over negative rad 3. I get theta in this problem to be, well, I guess if we take a quick moment and actually simplify it a little bit, 1 over negative rad 3 is negative rad 3 over 3, which is on our unit circle. Make ourselves a little bit easier. And know what? This is key. This tells me I'm in quadrant 2. So we're talking about a reference angle, in this case of 30 degrees in quadrant 2. So we have theta equals 5 pi over 6, which gives us 2 comma 5 pi over 6. All right, going reverse. We got x equals 2 cos pi over 4. So I got x equals, in this case, pi over 4 is rad 2 over 2 times 2. I got rad 2. Y equals, I got 2 sine pi over 4. That also gives me rad 2 over 2 times 2 for rad 2. I got rad 2 comma rad 2. The last one, I got x equals, trying to find room, 4 cos 4 pi over 3. So 4 times 4 pi over 3 is negative a half. 4 times negative a half, x is negative 2. And then, let's change the color because I'm wedging things in. Y equals 4 sine 4 pi over 3. So I got 4 times rad 3 over 2. 4 pi over 3, negative rad 3 over 2. To get negative 2, rad 3. So our coordinate is -2, comma, -2, rad 3. So the key thing about today is we have rectangular XY axes points, and now we have this new polar coordinate. They mean the exact same spot on a graph. One is just talking about its XY relationship. One is talking about its distance from the origin and the degrees or radians that's circled around the pole.